This is a demonstration as part of the ROS2 workshop showing how to use the Plotjuggler and debug and Swiri console apps. So in this, we've set up a Terminator window, and we're going to ROS2 launch the generic Turtle Sim simulator. This is based on Turtle Sim, and but gives it a generic interface in the sense of it monitors CMD val for motion commands and emits its position, its pose on the as a odometry message on the /odom topic. And so the Turtle Sim simulator has started. The turtle is at 5.5, 5.5 in the middle. Now we're going to start up the a group of action servers that listen for waypoint commands and drive straight commands and stop commands. And before we do that, we're going to start up Swiri console. I'm going to split this window in half and ROS launch Swiri so ROS2 launch. Still so much in the ROS1 habits. ROS3 run. Swiri console. So the value of starting Swiri console early is that you get to see the startup messages from each node. And so now we'll start the action servers, which is launched by the servers launch file. And in Swiri console, you'll see we got some messages from nodes. Drive straight odom node saying it's starting the action server, and same for stop and drive waypoints. Now we will start a bag file recording and record the waypoint path that the TurtleBot is about to traverse. So this scripted mover command line tells the robot controller to drive waypoints where the first waypoint is 8.4, second waypoint is at 2.2, third is at 3.3, and the fourth is at 5.5, 5.5, which is its starting point. So we hit enter on that, and we look at the messages coming out, and we can a bunch of messages came out on drive waypoints, and we can expand that. And it's giving feedback. Here's where it found it's at its target, so it stopped. then it's driving to the next waypoint at 8.4 and gives feedback as it goes. We're also seeing the feedback coming from the scripted mover client as it works its way around its course. So you can see the power of the Swiri console in terms of being able to see console output, logging output sent by each of the nodes in the system. So it's heading for 3.3 here. Could have achieved it, I would have thought. Oh, now it's moving back for going back home to 5.5, 5.5. Okay, so it finished its moves, and the mover client said it's exiting, which it did, and the drive waypoints action server said that it is done with the target list, and so the action finished with success. So now we will stop the bag file. And we'll call up Plotjuggler. And Kareem, stop me if you have any questions.
Sure.
Close that. Close that. Now, Plotjuggler remembers your topics, and I had previously run this and saved a layout, so I'm going to recall the layout that I saved with this button in the layout, and I saved it under the name TurtleSimNav. And this is actually a previous run. This is the data from a previous run. So we're going to import the new data. And we navigate up to the list of bag files. And the newest bag file is at 2215._51. The save layout actually remembers the last data file that you displayed, which was this preceding one. But now we want to plug in data from the new data file, the new bag file, and we select the metadata. And Plotjuggler remembers the topics that you selected last time you ran it. So we'll just say okay to all that. And this is the new plot, and we can grab the timeline, the playback head, and move along from when now command vel started quite some time after odometry started, because odometry started when the simulator started and started being recorded when the bag file recorder started. But here's where it started seeking to the first waypoint shown on the plot of command vel linear X. And you can see that the dot is moving along the two-dimensional 2D plot of the
XY
robot's path. So I'm just going to remove all of these curves and show you how to make this 2D plot. You want an XY coordinates, so we'll open up ODOM and go to pose, position, and then you want to click X and then shift click on Y to select both of them, and then right click and drag over to a plot where you want the XY plot. And it asks you if you want X on the plot to be this variable, the pose position / X. Yes, we do. And that's how you get the 2D plot. You can remove all curves. You can edit curves to remove one or more. You can turn curves off by just simply clicking them there to help clean up your display. So this is how the X position varied over time. So here we have both an XY plot of the robot's heading and a time plot of the X position within the robot's coordinate frame. And on this plot, we're showing a debug variable. And then the last useful bag examination tool is RQT bag. And we will just split this vertically, and we'll say ROS2 run QT bag, QT bag. So this is going to show us a packet or a message view of what we saw. So we will open the bag, the most recent bag. So these are the topics that are in the bag file, and the solid lines are just solid because there are so many messages in them that we're not seeing them. But an interesting time to look at and examine a bit more closely, perhaps, is where CommandVal is about to stop. It's about to stop emitting motion requests, but waypoint debug is still going, so it's still apparently moving. So we left click to place our cursor here, and we scroll in with the scroll wheel. And now you can start to see how there are a lot of pose messages, but relatively the CommandVal is coming at a slower rate, looks like about 10 hertz. Now to look at the contents of those messages, we can right click on the topic name and then say view raw, and we'll be able to drill down into the field, the values of each of the fields within that message at the time the cursor is on. And then we can step forward one message in this topic with the right arrow, and you can see it's jumping forward 100 milliseconds because it's a 10 hertz repeat rate on CommandVal. You can also jump to the end or the beginning of this plot. But a useful thing is to look at what else is going on in the system from a packet perspective, from a message perspective at this time. So we'll right click on ODOM and see what's happening with it. And view raw. Now let's zoom in, and zooming happens around the cursor position. So if you wanted to move back a little and say, hey, what's going on here? I see a fat bar there. What's that? You can left click Let's select odometry, and we can left click. Should be able to left click and place the cursor. I don't know why the cursor is jumping around oddly like that. Anyway, the point that I wanted to bring out is that these arrows let us move forwards in odometry messages as opposed to in command val messages. So we can see changes happening in a different variable that's operating at a different time frame. And you'll see as we move forwards with odometry, when we get a new command val message, which we're about to do here in the twist message will change. Oh, it didn't change, so it must not be changing its speed. It must be stuck on a constant speed. So that's how you use that. So RQT bag is more valuable for looking at variables, really at state variables. So for example, a waypoints debug state contains some state that's interesting to look at from a timeline perspective. And just zooming back out here in the bag file, we're a fair ways in from the end. And you can see that the waypoint debug message has an at target as false. But a little ways down the bag file, at target becomes true. So that's pretty interesting. What happened around that at target? What were the values of command val and X and Y when that happened? So we can zoom in, and so we're right here. We can go back one message in waypoint debug until we see at target. So at target was false. So we're right at the transition where this at target state transitioned from false to true. So that's where the robot considered it had met its goal. And this happened at, we can see the timeline, and it says it's at 123.164 seconds. So we can now transfer over to Plotjuggler and have a look at what happened at 123.64 in the bottom left, where we show the. Okay, so here's a little bit before, so about 2 seconds before it declared end, and we can see the robot in its XY position is just about at its stopping point. Its velocity has ramped down. It's now cruising along, and we can zoom in on this area by left clicking and mousing, and notice that the velocity at this point is 0.15, and you can see it's actually on the flat bit where it's approaching the waypoint at low speed, getting ready to stop. And we can see that X is at 5.63 and Y is at 5.63. So it's getting pretty close. It's getting within the acceptable error range of the 5.5 target. And the bearing to the waypoint is pretty close to 0, but it's about to increase sharply as it comes alongside the waypoint. So there you have a look at how to use 3 powerful tools. Query Console for looking at the console output of nodes as they run. And by the way, you can play back bag files and look at the console output with Swiri console. And then a graphical plotting program to look at the values of analog programs, analog variables, and the RQT bag GUI to let you look at state variable values as they change as ROS messages are emitted. Do you have any questions on how this whole thing hangs together, or any comments, Kareem?
Well, since that was our second run through of it, no, I don't at this point, but I really appreciate it, Paul. This is going to be very helpful when I get back to it after after finishing my ROS, my Docker migration troubles. But so I'll have a reference with this recording that I can look up while you're away on your trip, and
Okay.
help
Well,
refresh my memory.
There are a couple other things that. One thing about Swiri console is you have to close the GUI itself. You can't control C it, unfortunately. It's one of those oddities. So we'll terminate this program, and there are a few other things I think in the workshop content that are maybe worth talking about. But we've done all of these. So I'm going to stop recording, at least for now, and we can talk about some stuff. And if we think we're going to go somewhere interesting, we'll turn on recording again.
Okay.